Next point what we are going to see is the fluctuating stress. As already we have seen that when we are going to have the load which can apply on any component, it will induce the stress. And that's why there are, again, we can say same type of stress which will get induced in that component. And that stress, again, we are going to say that the fluctuating stress, then repeated, then alternating stress, and completely reversed or cyclic stress. In this case, if we are going to see the definitions, it will be remain same. Instead of only that load, the stress word will be come in picture. The stress which varies from minimum value to its maximum value of the same nature are called as fluctuating stress. Whereas the stress which are vary from 0 to certain maximum value are called as repeated stress. The stress which vary from minimum value to maximum value of the opposite nature are called as alternating stress. The stress which vary from one value of compressive to the same value of tensile or vice versa are known as completely reverse or cyclic stress. As we have seen in case of loads, the loads are also defined in the same manner. There is nothing but the fluctuating load, repeated load, then alternating load, and completely reversed load. That same loads are going to create the stress. So when we are going to say the stress will get induced in that component, it is a product of load only, applied load or applied force. So we can say the definitions of that fluctuating stress, repeated stress, alternating stress, and cyclic stress are parallel with that cyclic load and all that definitions which we have seen for the load. Now when we are going to see actually how that loads are, that means here if we are going to say the fluctuating stress. Now in yesterday's lecture, I think I have drawn one graph. On that graph, we have seen how the loads are going to vary, how that fluctuating load looks like when you are going to plot a graph of time versus the stress or load. Here, now time has mentioned on x-axis and stress has mentioned on y-axis. And how this repeated load is acting, that we are going to see. So, in this case, we are going to use some terms, and these terms are useful for further study. That's why these terms are important. Out of that, we'll say that somewhere the value of that value of that stress is going to become 0 somewhere. So here we are going to consider that stress value is 0. Okay. So when we are going to mention the stress on y-axis, its value is 0 where it is going to cross to this time axis. And well above when we are going to see the stress, that stress value we are going to take the reference of 0 axis and we are going to calculate or measure what are the stresses. Okay. Out of that, we are going to say this term which we are going to use is sigma mean. Okay, where sigma min mean is the minimum stresses which are induced in that component. Sigma max are the maximum stresses which are induced, and from that we are going to calculate mean stress and stress amplitude, as well as we are going to see what the stress range is, and are mentioned by the sigma suffix m, sigma suffix a, and sigma suffix r. These are the nomenclatures which we are going to use for describing this diagram. Now, what this diagram is indicating? This diagram indicates that the stress is going to increase while the time is passing and is reaching to its maximum value. That's why here the name has given as a sigma max. This is the maximum value of stress which that component bears or which get induced in that component. Then likewise, the stress is going to decrease after its maximum value, will come to the original point where it has been started and will get reduced. Okay, it may be case that the stress may start from the minimum range, but here it has not mentioned in that cyclic graph. So here is the minimum value of the stress, sigma min. Now, with the help of this sinusoidal curve, we are going to derive some quantities. What will be the value of mean stress, which is used for the further calculation of dimensions when we are going to design any component against this type of fluctuating stress. Then in that case, this mean stress is calculated by means of sigma max plus sigma minimum divided by 2. That will become the mean stress of this fluctuating stress. Now, as this is purely sinusoidal curve, in actual practice, it doesn't happen that the stress is going to follow the sinusoidal curve. It may have some complicated course, but we are going to simplify it to the sinusoidal curve. Okay, and for this sinusoidal curve, here it has been mentioned as the amplitude of the stress wave, and this amplitude of stress wave is calculated by means of sigma maximum minus sigma minimum divided by 2. Always it is not possible to provide these values in exam or in problem. Okay, so while we are going to solve this such type of problem, we have to extract some data from the given data in the statement. Just wait, just 1 minute. You can see this slide carefully because next slides are depend on the same slide. As we are going to see this sinusoidal curve, sorry for this interruption. So from this we can say we can extract one more term, that is the sigma r, that is range of the stress. This range of stress may vary for the different type of stress which we have seen. Okay. As far as this slide is concerned, do you have any question, anybody of you? Because these terms are important. And have you understood what the terms which are mentioned on this graph? Any question? Hello. Shall we move further?
Yes, sir.
Okay. Somebody has to respond. Okay, now second type which we have seen is the repeated type of stress. This repeated type of stress and fluctuating stress are vary from each other. Okay. Now in this case, what we have seen is at one side, this repetitive type of stress are inducing. Okay. And its value is going to become zero. If you are going to see in case of fluctuating type stress, then in case of fluctuating type of stress, this value may not become zero. Stress is above the zero line. Okay. Whereas in case of this repeated stress, this value of stress has to become zero then and then only we are going to call it as a repetitive type. Okay. That means once the tensile stresses are induced to its maximum value, the minimum value will become again zero. Though this sinusoidal curve has started from this point, which has drawn here for only for sake of understanding. Otherwise, this curve has started actually from this zero and it is like this. Okay. So from zero it has started, is going to reach to its maximum value. Again is going to come to the zero. That type of stress you are going to call as a repetitive type of stress. Okay. So in this case also, it is going to differ from the fluctuating stress by means of only condition that it is going to become zero. Okay. Now it doesn't mean that it is going to opposite side. Only thing is that the component is going to have relaxation, that is zero stress time will be there for that component. So that stress is going to become zero and to its maximum value. It is going to repeat. Okay. So it is called as repeated stress. And same way, the formulas which we have used in case of fluctuating type of stress, that same formulas we are going to use here. And for that, again, nomenclature is remaining same. That is sigma mean minimum stress, where it is going to become zero. Then maximum stress is denoted by sigma max. Mean stress are denoted by sigma m. Then amplitude of stress is denoted by sigma suffix a, whereas range of stress is denoted by sigma suffix r. And from this, we are going to calculate what will be the mean stress. Okay. So definitely this mean stresses are going to become maximum divided by 2 because minimum stresses are 0 in this case. Okay. But formula is used as same as we are used in fluctuating type of stress. Now this is going to become amplitude of this wave. Okay. Wave of stress. This value is mean stress. Sometimes this amplitude and mean stress are the equal. Okay, that depends upon values which are given. Whereas the maximum stresses are stresses which are induced from 0 to its maximum value and is the same as a range of that stress. This is related to the repeated type of stress. Is there any question? We'll move further. Now this reverse the stress. As the we have seen definition, this reverse stress are nothing but the stress which are changing their uh, magnitude from one side to other side also. That is nothing but they are changing their nature. Once they are going to have tensile nature, they are going to become compressive also. And one more condition is that whatever may be the tensile value has achieved by means of this type of stresses, same amount of compressive value is achieved by means of that stress. And in this case, the minimum stresses are nothing but the stresses which are going beyond the zero towards the opposite side. That value may be negative. So we have to consider that negative value and we have to calculate the mean stress. So that mean stresses are always zero in this case. Okay. And maximum stresses that we are going to consider either to the what we can say compressive side or to the tensile side. Okay. That depends upon how you are going to give the um, sign conventions. And range is going to vary from the tensile side to compressive side. Okay. And important thing is that as we are going to calculate the amplitude of that stress, okay, that is calculated by means of sigma max minus sigma minimum, okay, divided by 2. So this amplitude of stress is the important quantity which we are going to use while designing the components under this type of stresses. Once this is over, then we are going to move to the further point, next point which we are going to see, and that is the fatigue failure. Before going to this point, let me have some questions related to these three types of stresses which we have seen graphically right now. Hello, are you ready? So how we can differ this fluctuating type stress from the reverse stress? How one can recognize? Is there any criteria by means of which we can recognize this? These stresses, this problem statement is going to give us idea that these are the repetitive type stresses. Sushant Zadav, will you please unmute yourself? Hello, Sushant Zadav. Huh. Did you get my question, Sushant? Huh. So how we can
Hello. Yes,
differ
sir.
it? Fluctuating, we can say if we read the problem statement and if we want to solve that problem, then how we can say that this is not this is fluctuating type of problem, is not repetitive type or is not reverse type. Huh? In case of fluctuating load, curve will be above x-axis. X-axis and y-axis, they are just defined. Okay. Yes, you are right. But we can say the stress value is not going to become zero at all in that case if the fluctuating type of stresses are there. No doubt that calculation will not come wrong because either it will be repetitive type or it will be fluctuating type or it will be reverse type. It doesn't matter because calculations are going to give us same values which we are going to give the input to the mean stress and amplitude of the stress. Okay. Then range also we are going to get from that minimum and maximum values of the stress. But while we are going to categorize that stresses, that at that time mathematically they doesn't differ. Mathematically just you are going to put the values and values are going to give us that answers for the mean and amplitude and range. Okay. So that's why if you see the mathematical formulas for all these three types, then the formulas are going to remain same. Only just that values are going to differ. Okay. Yes, right. So we got the answer. I think you might have understood uh, what we have explained right now. But if you do any question, you are free to ask before going to the further point. Hello. If not, we'll go to
Hello,
the next
hello,
slide.
sir.
Yes, yes.
Hello.
Yes, you are audible.
Will you
Sushant
please
Zadu.
explain fluctuating stress and reverse stress again?
Fluctuating type stress and reverse type of stress. These are the fluctuating stresses, where these fluctuating stresses are
Yeah.
on the one side of that zero stress. And these are not going to become zero at all. They are never zero. Just when they are starting, when the stress is induced, when that component is loaded initially, it may be possible that that the value may be zero. From here, it may start, but after that, they are not going to become zero, and they are to the one side of that zero stress level. If they are in tensile nature, will remain in tensile nature only, and if they are in compressive nature, they will remain in the compressive nature only. Whereas in case of this reverse type, they are first of all maybe in compressive, then afterwards tensile, or first of all they will tensile, later on compressive. That means they are going to change from compressive to tensile, and their value, that is amplitude, is going to remain same in tensile side and in compressive side. Do you get it? Okay, got the point.
Yes, sir.
Yeah, okay, no problem. Anybody else? Uh, okay, I will take present now. And to the next lecture, we will see the fatigue failure. The time is over, and your CC has instructed me to follow the timetable strictly.